Hello guys, I'm YOKESHWAR from Veltech, Institute of Science and Technology, and today I'm just going to focus explaining my project that is chronic disease prediction using machine learning. So our project is like about predicting a disease. Okay, normally what we call as in machine learning we use prediction algorithms to just predict the disease whether a person has a disease or not. So here I'll show you a data list of patients which may or may not have disease. Okay, in this project we have a disease called chronic kidney disease. Before we start explaining the project, I just have to explain you what is chronic kidney disease condition. Okay, it's a condition where a patient whose kidney functionality stops. Okay, that's what we call as what do you say? A kidney can't able to function anymore. Okay, that's end of kidney's function. So in this project, we just collected a clinical data. Consists of age and its blood pressure, specific gravity of an arm. These are like medical terms. Okay, RBC. Most probably, few of the terms everyone is like similar with. Uh, I think hemoglobin, yeah, PCB. It's count of white blood cells. It's appetite. It's kind of proteins and other plants. And this is class. Okay, this consists of whether the patients, given the list, have the disease, chronic kidney disease or not chronic disease. Just mentioned like CKD, not CKD. Just to make sure the file has an data of pre-existing. That's what we call as historic data. So we just made an prediction system. Okay, that could predict uh, whether the person has kidney or not, and it must have a good performance as well, comparatively from the other pre-existing algorithms as well. So just come up with one second guys, I'm sorry. I'll just come up with something called four algorithms. Before we start up with the algorithms, I just want to explain pre-process things and other things. Okay, we just imported packages like pandas, numpy, login, and xskill and cbone. Here, the most of the packages were like pandas and numpy are totally for datagrams, and then numpy is it's in Python. We use numpy for most probably for the something that involves array and other things. Okay, so just come with and the other matply, cbone, everything was used with plotting graphs. You know, prediction doesn't like just with the naming it is CKD or not. Okay, only with comparison and then plotting things we can come to a conclusion. So yeah, we are just uploaded a file. I think we show this file. This is that file. The patient may have CKD, not CKD, whatever it is. We just got a file of like around 400 items. Yeah, it's limited one, so we just got only 400. And this file may consist of like empty values, null values. Okay, usually in the real-time data, a person may have taken the text test for specific gravity, may or may not have taken. So for understanding purpose how the system will run if there is null value. So just we took data with null values. Okay, so I'm going to make it work even without something a data without a value as well. Okay, so here is it. Just upload the data, and we are just checking anything is null value or something, and just we found how much data I'm going to make it as training one as a test data. So I just come up with like 70% of the data for training, and the rest 20-30% is for testing. So yes, this is what I said. Okay, target class valuation based on it. What I said. This number of variable related to target value. Yeah, here zeros and ones are like zero is for CKD and one is not CKD. It's zero is negative, one is it's positive. Okay, we just replaced the terms in medical. Okay, in medical positive means the person has a CKD. Okay, but in this it's like zero means negative. Yeah, if the person has negative, it means he has CKD, and one means not having CKD. CKD is like chronic disease. Okay, and I just plotted a heat map just to make sure that which of the following what do you call it? Yeah, data as higher what is it relation to the person, like what I say, we call it a set the person, how it is how this variables related to a person is having CKD or not. Okay, so here after plotting the heat map, just to come to a conclusion, like hemoglobin and specific gravity have high correlation with the target value. Target value is like the person has CKD or not. Okay, so this is how it goes. And then we just applied first I already mentioned like four algorithms. We just tried four algorithms. The four is something like I referred so many reference papers, and most of them tried this all these algorithms. So I just come up with like trying these algorithms with a better what do you call it, parameters, as well as a better model, research model. So first I applied uh, SVC, what you call as support vector machine. Okay, it's one of the like unsupervised. Yeah, it's supervised algorithm. Yeah, exactly. We use it, and we just after applying everything, I just run it, and we got an score like 99% of accuracy. That's like only one data. Okay, I think we say already mentioned like 120 data is for testing. Okay, that only one data is like this isn't got the correct output. For the rest of the data, we got for zero and one for one. This is how it goes. And for performance calculation, I just come up with accuracy only. I don't want to go for recall or anything. Okay, just for showing what are the performance parameter, I just used precision, accuracy, recall, and F1 score. For accuracy, I got 91 in SVM, and but the scores are not like static one. It's changing every time I execute, and every time I upload the same file. Okay, so I'll say the range it will comes. Okay, it's like 95 to 99. All the algorithms I applied was around 95 to 99. It doesn't come down from that. Okay, so we can make a conclusion like the algorithm like around 100%, so we don't get much of the errors while executing. And this is comparison for the variables for calculations we used in SVM. Yeah, parameters, what we call it parameters. I use C, gamma, kernel, and we just comparing, yeah, plotting graph to compare which has the best parameter, and which has the best score. Yeah, that's it. And then is coming to the next algorithm we applied. It's KNN. I think everyone knows. Okay, KNN. I initially mentioned like we have null values somewhere. Okay, only KNN can overcome this null values. I think I'll show you one more thing. I think I left it. Here's the thing. Yeah, to replace null values, okay, non values. Okay, I just applied uh, what you call KNN missing values. Okay, this is what, yeah, this line is what I trying to make it. Okay, KNN missing value imputer. Okay, imputer is like uh, KNN imputer, what you do know, right? It will find the five neighboring values of the missing function, missing value. Okay, suppose I consider this is a specific value, it will come go for the other five values, and just find the mean square of the four values, and just find the value that is almost similar to the original one. It's almost similar. Okay, it doesn't affect the result. Most probably it doesn't affect the result. Okay, after completing with this algorithm, yeah, KN will go to straight to KN. It's, yeah, we got it like around 97, and just we had left with three mismatched data. It's okay, it's not a big trouble. I still think we need so much training, because I just applied only 400 data for training and testing. I think that won't be enough, but this is what we got to do the project. So this is the limitation. Yeah, and we got our 97. That's quite high to the other algorithms. Okay, and then come up with a decision tree. Okay, so it's one of the best performing algorithms. Decision tree, random forest, and then support vector. Those were like best performing supervised algorithms. And even this algorithm we got like 99%. It's quite faster to other algorithms. SVM and this algorithm, SVM, yeah, support vector and decision tree were quite faster than other algorithms. But only one thing is the next algorithm is random forest. It's performing well, but it doesn't have better what do you call as execution speed. Yeah, compared to all the algorithms, this has a lower execution speed, but it has a better performance of 99%. Just like other algorithm, only one does problem. So after like just coming with plotting the ranks for it. Just come with support vector, random tree, decision tree. All three algorithm performs well, and plotting the graph. But these ranks were temporary actually, because even after executing now, if I try to upload the same file again and just execute it, maybe the result will be different from other. Those are the nature of the algorithms, so we don't get the same thing every time. That's what prediction algorithms were. So after applying, I can come to conclusion, right? Random forest, decision tree, and separator, everything runs perfectly. uh, KNN, it runs with a good performance, but still it lacks somewhere from the other three. Even if I'm going to get a 96 for random forest tunnel, but it's quite lower than every time I execute it, I'm getting quite lower score compared to the other. So that's a problem with KNN. But it has one best quality is we don't need to worry about the null values when applying KNN, because this is the one just making all this algorithm looking better, I think so. So here's our conclusion for yeah, better prediction systems. I can't come to a particular one, but all the algorithm performs well compared to the others. So here we say conclude here. This is our project of prediction system. We almost got our objective here. Okay, guys, thanks for watching, and hope you got something, some knowledge from this. And if you want the code or something you can just tag me over the comments so that I can help you out with it. And if you need something teaching over this content, anything related to the content, or you need something this data set file, just contact me through the comment section. Okay, guys, thanks for watching. Hope you like and share. Thanks.